everyone. Myself, Dr. Tarkeshwar Verma from CSVTU. Today's lecture topic is Mineralogy. Today's lecture contains our definition of mineralogy, importance of mineralogy, basic characteristics of minerals, classification of minerals, crystal structures, physical properties of the minerals, optical properties of minerals, identification techniques of minerals, famous minerals and gemstone and their applications. So, let's start with the definition of mineralogy. Mineralogy is the branch of geology that serves as a scientific compass for the exploring and define the minerals, nature's hidden gems and their compose the very foundation of the earth crust. Mineralogy acts as a bridge between the tangible world we see and unseen. Geological process shaping our planets. By studying minerals, we gain insight into the earth evolution, environment, condition and intricate dance of element at the microscopic level. Mineralogy is a journey into the heart of earth composition where the language of the crystal and stories embedded in a mineral structure awaited exploration and interpretation. Now, important of the mineralogy. Understanding the earth composition. Mineralogy is the instrumental and unraveling the interacting composition of earth crust. By studying the top types, distribution and the properties of mineral, geologists gain insight into the geological process that have shaped our planets over millions of years. This understanding of the fundamental to the descripting earth story and evolution. Economic significance. Economic significance that says the economic impact the mineralogy is the immense. It plays the very pivotal role to the discovery, extraction and the utilization of the valuable mineral and resources. Mining industry rely on the mineralogical study to identify one deposit, access their economical valuability and optimize extraction processes. From precious metal to the industrial minerals, mineralogy is the compass guiding economical activities in the mining sector. Next one is the environmental impact. Mineralogical contribution significantly to the excessive the environmental impact of various mineral and mining activities. Understanding how minerals interact with the environment, their potential for the leaching harmful elements and their impact on ecosystem is the crucial for the sustainable resources management. Environmental mineralogy have to mitigate adverse effect of the guides responsible mining practices. Next is the geology and petrology. Mineralogy is the intimately linked with the geology and petrology. Geologists use mineralogical knowledge to identify rock types, decipher the geological history. Geologists use mineralogical knowledge of the identify rock types and the geological history of the region and understand the tectonic process of shape earth crust. In petrology, the study rocks, mineralogical analysis provide the essential information about rock formation, metamorphic process and the condition under which rocks have evolved. Mineralogy is not only the window into the geological past but is also compass guiding economical activities, influencing environmental management and forming the bedrock of geology and petrology. Its multifaceted importance underscores the role of the concert stone in the broader field of the earth science. Next, our topic is the basic characteristics of the mineral. Minerals have some specific characteristics. These are the just like inorganic nature. Minerals are fundamentally inorganic substance. Unlike organic compounds derived from the living organism, minerals are formed through the geological process involving non-living elements and the compounds. This characteristics sets them apart from the realm of the organic chemistry. Next characteristic is the naturally occurring. Minerals are produced of natural processes and the occurrence. They are not artificially created or synthesized by the human activities. The natural formation of the minerals involve various geological phenomena such as the cooling and solidification of molten rock, precipitation from the solution or the crystallization from the magma. Third is characteristic is the solid substance. The definition of the features of mineral in the solid state, its natural normal temperature and presence our earth surface. While some minerals may exhibit variation in hardness, they generally exist as a solid with the well-defined structure. The characteristics distinguishable mineral from the liquid and gases. 4 is the specific chemicals composition. Mineral possesses specific and well-defined chemical compositions. Each mineral is composed of a particular combination of the chemical element in a fixed properties. This characteristics contributes to the unique properties and the behavior exhibited by different minerals. For example, quartz is composed of silicon oxide. Next characteristic is the crystalline structure. The atom, ions or a molecule within the minerals are arranged in a regular order and the repeating pattern known as the crystalline structure. This organized arrangement gives the minerals their distinct geometric shape and optical properties. The study of crystallography is crucial in understanding the internal structure of the minerals. Now, the next topic is the classification of the minerals. Classification is mineral is the first one is the silicates. For example, silicates are the most embedded group of the minerals and the characterized by a silicon oxygen tetrahedral structure. They consist about 90% earth crust. Example, quartz composed of silicon oxide. It is the common mineral of the various crystalline form. Next one is the carbonates. Carbonates are minerals that contain a carbonate ions as a structural component. They often form in a sedimentary environments. Example, calcite composed of calcium carbonate. It is the major constituent of limestone and marble. Next one is the oxide. Example is the hematite. Oxide are the minerals that consist of metal cations bonded to oxygen. They often form the environments with a high oxygen level. Example is the hematite. An iron oxide, hematite is the common mineral with the metallic luster after appearing silver to black. Next one is the sulfide. Sulfides are the minerals that contain sulfur as a major components and often from the hydrothermal environments. Pyrite is the example, is also known as the fools of gold. Pyrite is a iron sulfide which is the brassy yellow colors. Next one is the native element. Native element is the mineral that are the composed of the single element in its pure form. They are relatively rare component to the our mineral group. Just example is the gold. An ionic native element, gold occurs naturally as a nuggets or a grains and has been prized for its beauty and value throughout history. Our next topic is the crystal system. They define the how minerals are arranged and shaped. So now let's start the crystal system. Crystal system categorize mineral based on the geometrical arrangement of the atoms and their crystal lattice structure. There are the 7 main crystal systems, each with the unique symmetry and characteristics. Angles between the crystallography axis and crystal systems are: first is the cubic, second is the tetragonal, third is the orthorhombic, and fourth is the hexagonal, fifth is the tetragonal, sixth is the monoclinic, seven is the triclinic. All these are the shows the different kind of the crystal symmetry. Now we are describe the different example of the crystal system. First is the cubic. The example of the cubic structure is the pyrite, a common sulfide mineral with the cubic crystal structure, often forming distributed cube or example is the pyrite, a common sulfide mineral with the cubic crystal structure, often occurring the tetragonal prismatic crystals. Zirconium silicate commonly found in the rocks, often occurring the tetragonal prismatic crystal. Third one is the orthorhombic. Sulfur element sulfur often crystallize in the orthorhombic form, forming the rhombic prism. Fourth is the hexagonal. Example of this symmetry is the quartz. The hexagonal crystal system is the notable for the quartz crystals. Fifth is the trigonal, calcite. The example of this symmetry is the calcite, a carbonate minerals with the trigonal symmetry, often forming the rhomboedral crystal. Sixth is the monoclinic. The example of the monoclinic is the gypsum, the sulfate mineral commonly occurring the monoclinic crystal, including enclosed prism. Next symmetry is the triclinic, microcalcine. The example of that 7th symmetry is the microcalcine. Next our topic is the physical properties of the mineral. So first physical properties of the mineral is hardness. Hardness refer to the mineral's resistance to the stretching. Mohs scale is the mineral hardness, is the quantitative scale used to characterize the stretch resistance of the various minerals. So all minerals are measured in a scale between scale from 1 to 10, where minerals are ranked based on their hardness. Example: talc can be stretched with the fingernail. Quartz, its hardness is very hard. Its number is also 7. Next is the diamond, that is the point is the in a Mohs scale is the 10, hardest mineral on the scale. Cleavage and the fracture. Cleavage, the way the mineral breaks along the plane of weakness, producing flat and smooth surface. Next one is the fracture. the way of mineral break when no cleavage planes are presented, resulting in irregular or a rough surface. The example of the both, first is the mica, second is the quartz. Mica is the exhibit perfect basalt cleavage breaking into the sheet. Quartz typically shown the conchoid fractures producing curved cell-like surface. Third physical properties is the color and streak. Color is the visible human eyes of the mineral when observed in a normal light. The color of the powdered form of the mineral when scraped across a surface. Example, hematite and hematite. Example is the hematite. Metallic gray is in a color but leaves in a red brown streak. Our fourth physical property is the specific gravity. So, it is the ratio of the mineral's weight to the weight of a unequal volume of the water. Example of that category is the quartz, has lower specific gravity compared to the metallic minerals. Fifth is the luster. Definition: luster refer to the way light interact with the surface of the minerals. Types: the metallic luster resemble of the appearance of the metal. Non-metallic luster include various types such as the various partially silky and dull. So, example of that particular is the gold exhibit the metallic luster, quartz display the glassy luster. Understanding these physical properties is the essential to the mineral identification and classification. Each property provides valuable information about the mineral's composition, structure and geological history. Mineralogists use two combination of these properties to identify and categorize the vast array of the minerals found on earth. Next, our main topic is the optical properties of the mineral. We already discussed about the physical property. Now we are describe and we are talk about the optical properties of the mineralogy. Optical mineralogy explore how mineral interact with the light, providing valuable insight into their internal structure and composition. Microscopy is the use to optimize this characteristic. Microscopy is the thin section of the mineral are often studied under the petrological microscope to observe optical properties. Birefringence or double refraction. Second one is the double refraction. That refraction occurs when the mineral splits on the single light ray into the two rays, each wavelength, each traveling at the different speed. So the effect of this property, the phenomena result in a appearance the interfaces colors when the viewed under the polarized light. The example of that characteristic is the calcite, exhibit strong bifractional and is often used to the standard mineralogy. Pleochromies, that refer to the phenomena where the mineral appear to have different colors when viewed from the different angles. Reason behind that is the cost of the variation in the absorption of the light along different crystallographic axes. Example, iolite demonstrates this property, showing the violet, blue and yellowish brown colors depending on their angle of observation. Next property is the twinning. Twinning occurs when two or more crystals share the common lattice plane or the axis, leading and the repeated patterns. They have different types. First is the contact twinning. Crystals are joined along the common plane. Next is the penetration tuning. Crystals share a common axis. The example of this tuning, the Strolite. Often the display characteristic cross the shape twins. Next our topic is the identification techniques. Under this section we are discuss about the different techniques. First is the X-ray diffraction. Its short form is the XRD. XRD is the based on the diffraction of the X-ray by crystal lattice. When X-ray pass through the crystal, they undergo the constructive interference producing diffraction pattern that are the characteristics of the crystal structure. Generally use this instrument to identify the minerals by analyzing the angles and intersect by the different crystal diffraction peaks. XRT particularly effective in the determining the crystalline structure of the minerals. Second one is the scanning electron microscopy. Its short name is the SEM or SEM. SEM utilize focused beam to electrons to scan the surface of the specimen. It provides the high resolution images and provides information about the topology, morphology and composition of the minerals. Reveals detailed surface features and the micro to nano scales, identification and characterization. This is that can be obtained from by particular this instrument. Next is the petrolography microscopy. Microscopy involves the examining the section of the minerals under polarized light. Fourth is the spectroscopy. Spectroscopy involves the study of the interaction between the matter and electromagnetic radiation. These all identification techniques play the very important role in a field of the mineralogy, providing mineralogists with delivered to tools to analyze and understand the properties of the mineral in a different scale. The applications of the mineralogy is the first is the construction materials. Next our topic is the minerals uses and application. First is the construction materials. Common material use first is the quartz and found in the quartz found in a stand and used in the production of concrete and glass, and limestone. It's used to production of the cement and arrangement of the construction. Application of the mineralogy first is the concrete production, second glass manufacturing, in a gemstone and jewelry, industrial uses, economic resources, steel production, aluminum production, and other application is the resource exploration, mining in extraction, construction materials, environmental assessment, geological mapping, oil and gas exploration, gemology and jewelry, archaeological studies, cosmetic and pharmaceutical industries. So, mineralogy play the very important role in a various industries, serving as a raw material for the construction, providing value in a jewelry, contributing to the functionality of everyday products, and the serving as a economical resources that drive the industrial activities. The provide the application of minerals highlight of their significance in a shaping modern societies and economics. Thank you.